here. And we'll get a chance to talk at the end of the hour. We'll take a few minutes and talk about what you're responsible for. Okay, if you can, we'll go into a breakout room and I'll explain it. All right. Hey, Leadin. Hey, Sabrina. How are you? Natalia. Good to see you. Naomi was here and then must have been kicked out. There you are, Naomi. You're back online. So, all right, just let you guys know that. Yeah, mine was been doing that too. I'm gonna have to get my. I'm gonna go off this camera here. I I have a Ethernet cord. I have to plug it into the printer to get the printer to work, but I click it on and it works better. So let's talk about what's going on. So tomorrow, I'm taking a personal day off. So there's just too many things for me to do. So I'm taking, a personal day. So 10/5. Okay. So 10/5 is going to be async, ASYNC day. All right, so I'm going to be doing some review videos, and I'll do some quizzes, lessons for bonus. Quiz is lessons. Okay, so, and also I had somebody asked about Monday the 9th is a holiday. Monday is a holiday, so it's a 3-day weekend, right? Um, and it is, somebody asked if they had to come to class or had to do their 5 hours. So it's no class, have fun, right? No class, have fun. How'd that get up there? No class, have fun. Control X and put that down here. See if I can get it in there. Come up. There you had no class, have fun. Hopefully it's a good. I don't see that the weather is going to be very good this weekend. So, hey, Akila, how are you? Oh, you're on your phone. Yeah. Okay. Did you get a computer, Aaliyah? Is that how I say your name, Aaliyah? Sorry, you're late too. You're not too late. 2 minutes. I'm just asking Aaliyah if I'm pronouncing her name right. Oh, your name is hard to say. Okay. All right. All right. So can't call you Allie. Hey, Kimsey. Do you have a nickname that we could call you? Yeah, Kimsey is Kimmy. Yep, yep. I'm talking about AL. Oh, I picked it. Luna. Okay. All right. Let me do it. Let me put Luna in there. Good job. That's it much. Let me see where you are. Okay. It's on my second page. Where are you? No, didn't show up on my first page, my page here. Okay, Luna. All right. Well, good to meet you. And I had several people that were new today, but you look like you're the only one that's shown up. Let me see. Anybody else? Uh, so, Luna, you kind of have, it's like people are saying your name wrong and you're going, oh, man, can't get this right. Can't get this right. and it's like you have to put up with it. Ah, I know. I like that nickname. Me too. All right, so we are going to. Where are we here? We're going to do a little quizzes thing to see how you guys are doing, and we're going to do isotope review. Isotope review. And where are you? My library. My library. Okay. Okay, where are you? What did I do? Okay, explore. I did the ion thing. IONS, ions. Here it is. There it is. I found it, but it was not where I thought it was going to be. So I'm going to start a live quiz for you guys, and going to be classic, 10 questions. See how that works. Continue. Wait a minute. Did I do this right? Let me try this again. Oh, all right. Okay, let me go back over here. Let me put my camera off because it's going to be in my background here. So, okay, explore. Guns. Yep. Doesn't look like the same one that I did before. There we go. It'll have to work. Wasn't the same one. Classic. Okay, that works. That works. That works. I just wasted 7 minutes. All right. So here is the link. What did they? Luna Packs. Cool. All right. So I got to put my settings so that I get notification about chat messages and joining because I sometimes forget to look at the screen. So if you will be so kind, yeah, you guys are doing a great job. First name, last initial, Leiden Johnson, forgot his J. It's all right. I remember the last name. Hayden, Kimmy. I'm getting to get it. Thanks, Luna. So we've got 23 people. I'd like to get AJ in there. Is AJ in there? AJ not in there? Raven's in there. Samayo. Bubbles. Who the heck is Bubbles? Who's Bubbles? Come on, tell me. All right. Better remind me because I don't remember. Oh, guys, yeah, you're sending the bubbles up. Rosa. Hey, Rosa. Thank you for getting in here. All right. So we talked about ions yesterday, cations and anions. So let's see how you guys do. How you do. All right. So 10 questions. You guys can hear the beat now. newcomers, there's the form there. All right. Close it there. Francisco. And who's Bubbles again? Who's Bubbles again? Akila. Okay, Keela. All right. So a couple people I want to see at the end of the class here when we break into groups. Keela and Noah and our new person Luna. Okay, so if you guys can do that, Akila, are you okay with that? Right at the end of the hour, last 15 minutes? Sure. And Noah, are you there? Can you do that as well? You do that as well, Noah? Maybe not. I'll see. I'll check with him again. All right. So today we're going to talk about isotopes. So remember, tomorrow is async day, quizzes, lesson. This is a 3-day weekend. So we're going to be talking about isotopes. All right. So it is a lesson that let me do this again. Big, big, big. So isotope lesson is so this is going to be kind of different. Isotope lesson. All right, so this lesson counts as either bonus, so it's a quizzes bonus, or it becomes W7 assignment 1. So if you didn't do W7 assignment 1, it counts as that. So when you sign into it, let me know if you want credit for that. You may have not done that assignment, so this is going to count as 15 points. But if you've done the assignment, if you've done the lesson from yesterday, then it'll count as bonus. All right. Okay. Hey, AJ, I missed you. Did you just get here? All right. I'm glad you made it. All right. So we're going to do the bonus, and then and for breakout rooms. So breakout room, I have some room bonus. It's individual. It's on the periodic table. So it's a periodic table, and I'll give you that link. All right, so I'll give you that link. It's kind of moving ahead. And then what I want is Luna and Aquila. I spelled it right. And Noah see me in a breakout room. Um, at that in about 30 minutes. Okay. All right. So that's what I want to have happen. So let's go to this is the assignment. This is isotopes. And again, Luna, you are you will get credit on this. Basically, I teach the lesson, and then we ask questions. We ask questions as we go along, and you'll get credit for this. This is kind of a new thing for me. So let me show you the lesson here. All right. And it's another quizzes thing. All right. So I'm going to give you this link. All right. Here we go. And so Noah, if you can text me telling me that, chat with me telling me that you can make it to this live breakout room, I would appreciate it. There you guys go. Put your names in there. I appreciate it. Here is the link. I also put it in the shared notes if you get kicked out there as well. And breakout room, I'm sending a note message to Noah. You could text me back. All right, so we got 11 out of 26, almost half. Any other new people here today? Any other new people that I did not see? It looks like I've got everybody. All right. Okay, so let's start this. Okay, so isotopes are what our topic is on. So isotopes, and I don't like this particular slide, so I'm going to move on. Let me double check here. I don't think I have the sound hooked up to this one, so I'm going to share this again, make sure I've got the sound because sometimes forget to flip the switch for sound. There we go. Okay, so isotopes is what we're talking about today, review. So an isotope is an atom that has a different number of it has the same number of protons but a different number of neutrons. Okay, so in this particular case, iso means same, S-A-M-E, and topes mean place. And reason they say that is because in the periodic table, kind of looks like this. right? And carbon's over here somewhere. So the isotopes all are in the same place. They did not move, okay? So that's why they call it isotopes. So the atom has the same number of protons. So remember, that's the DNA. The proton, the number of protons tells me what it is. So protons like this, if I look at the periodic table, carbon has 6. The atomic number, all right, is 6. Remember, that's the number of protons, which is the plus charge in the nucleus. Has a mass of 12, or atomic mass of 12. Which is protons plus your neutrons, 0 charge. Okay, but there are also some carbons that say 6, 13, and carbons that say 6, 14, carbon 14. So those are isotopes. What's happening here is the neutrons, there are more neutrons here. Protons are the same. Remember, 6 plus 7 makes 13. 6 plus 8 makes 14. So that's a review, right? So let me give you, so that's a kind of a quick overview. Let's take a look at this video real quick. It's very short. Can you guys hear that okay?
Not all atoms of an element are exactly the same.
All right,
For
thanks,
instance,
Sabrina.
here's an example of a carbon atom
Rock,
in its most
guys.
common
Thank you
form.
much.
Notice that it has 6 protons and 6 neutrons in its nucleus. The fact that it has 6 protons is what makes it an atom of carbon. However, the number of neutrons can vary between individual carbon atoms. These variations are called isotopes. Isotopes are atoms of the same element that differ only in the number of neutrons present in the nucleus. Here's one example of a carbon isotope, carbon-13. Notice that while the number of protons in carbon-13 remains at 6, the number of neutrons has increased from 6 to 7. This gives the carbon atom a slightly higher atomic mass than carbon-12, but chemically, carbon-13 still behaves in the same manner as carbon-12. Another carbon isotope is carbon-14. Carbon-14 has the characteristic 6 protons found in all carbon atoms, but in this case it has 8 neutrons. In some cases, isotopes may be unstable or radioactive. Radioactive atoms emit energy or subatomic particles in order to return to a stable state. This is the case with carbon-14. Radioactive carbon-14 has a number of applications in science. Since carbon is found in all living organisms and the decay rate is well documented, we can use carbon-14 as a way of dating how old a sample of tissue may be by comparing ratios of carbon-12 and carbon-14. Carbon-14 dating is commonly used in forensic studies and in studying archaeological remains.
Ah, okay. It's going to a movie. I missed something there. Okay, AJ, 27th. Okay, you're telling people you're going to a movie. All right. So are people going to be there? All right. So let's take a look at this full question. What's an isotope? I'll help you out. It's not a charged atom. It's not a neutral atom. You got two choices: atom with different amount of neutrons or atom with different amount of protons. See how you're doing on this one. Atom with the different amount of protons or neutrons. See if you paid attention to that video. See if you paid attention. All right, you got 30 seconds. Bubbles. Lead in. Got 30 seconds. Come on. Oh, all right. Got them all. Got them all. How did you guys do? Let me see the chart. Uh-oh. Okay. So we're talking about a different amount of neutrons. Remember, protons is the DNA, right? So if I change the protons, it wouldn't look like this. It wouldn't look like C6, okay, and 12. If I change the protons to 7, it turns into nitrogen, right? So so we're not changing protons, we're changing neutrons, okay? That's what's going on here. Neutrons, so it's slightly heavier, as the video said, and it's also maybe radioactive, like the carbon 14. So be careful. It's not a neutral atom, right? It's talking about neutrons. That's in the nucleus. How about this one? Let's see if you got this one. Isotopes of an element have different number of, hopefully you get this one, have different number of what? 50 seconds. Let's get them in there. All right, guys, let's pay attention. Elroy, you made a movie. Let's keep the focus on the assignment, please, especially if you're going to get credit for it, okay? Aiden, you're kind of inciting the other people here to talk. So come on, come on. All right, you're on notice there, AJ. On notice. How'd we do? How'd we do? Did we get it right? Yes. Still, people said electrons. Uh-oh. Okay, neutrons. I'm still trying to get 100%, right? Some people said protons. We said it wasn't protons last time, and now it's somebody put protons. So paying attention, ladies and gentlemen. Okay, so here's a different way of writing these down, and it's a little more complicated. One way of writing isotopes, because they don't show up in the periodic table, is that you write it as the element, symbol, and 12. So this is carbon 12, and then we use the periodic table to figure out. So carbon 12 has, okay, so it's got a mass of 12. All right, so it's 12, which is protons plus neutrons. Okay, neutrons are zero charge, protons are positive charge. We look here on the periodic table, the smaller whole number is the number of protons. So 6 plus the number of neutrons equal 12. Or you could just say, I'm going to take 6 away from that. So this has 6 neutrons. Take 6 away from that. This is going to have 7 neutrons, and then 6 away from that is going to have 8 neutrons. Oops, 8 neutrons. All right, so that's how we figure out the number of neutrons in it. But if you notice, all we're doing is changing the neutrons. The neutrons are only things that are changing. The carbon 6 is still the same. So we have to, this is the total. So we put the C12, which is the total, carbon 12, or C13 to tell us which different one. Okay? So that is what that is all about. So we're talking about neutrons here, just to remind yourself, because you guys have a tendency to drift off. It's after lunch. Okay, so how many neutrons in this particular one? So remember, you take the 6. All right, let me get my pen back here. I got to use my mouse to do this one. So you take the 6 and subtract it from here. What do you get? 6 and subtract. 2 seconds, 1 second. Oh, let's see how many people got this one right. Uh-oh. Okay, so 6, let me help you out here, ladies and gentlemen. 6 from 14. So we're doing subtraction here. All right, 14 minus 6 is 8 right here. We got 4 people. 4 people said 6 and 6. 6 and 6 is not 12. We're not using this number. We're using that number to take, remember the mass is the protons plus the neutrons. Okay, so we take what we know. We know that there's 6 protons there, so we take the 6 from there and subtract it from the 14. So hopefully you do better on this next one. All right, next one. All right, how many neutrons does this atom of neon 22 have? How many atoms? Okay, remember, I'll help you out here. Use this 10. Subtract it from 22. What do you get? And 22 minus 10, that'll tell you how many neutrons are in there. How'd we do? Did we get better? Did we get better? Yes, we did get better. We had like 8 people get that one right. Instead of, yes, we had 12 people get that right. Nice. 3 people said 10. So you're thinking the 22 minus 10. You're not doing 22 minus 10. You're just saying it must be the 10. Or you're subtracting it from the 20.018. All right, so that's okay. We're still having some try to get everybody on board here. Still being a problem. All right, how many from this sodium? Oops, full question. So we use the 11, right? Put it under here. Take 11 away from 24. What do you get? What do you get? Okay, got everybody? Khalid, come on, Kimmy. Hey, Kimmy is not there. So that was 13. All right, so this is a little different. Okay, now you've got 76 protons and 14 neutrons. Now we've got to write it as either osmium 114, osmium 76, and osmium 190. It's not this one. So remember this, to write this as the mass, we have to add these two together, right? 76 plus 114. Don't do that one. So don't write it as osmium 114 because that's a osmium just part of the mass, and osmium 76 is part of the mass. But we've got to do it the other way here. Okay, how many are we doing? All right, almost there. 15 seconds. Come on, Bubbles. There we go. Come on, there we are. Okay, yeah, most of you guys got it. Some people wanted to say it's 70 osmium 76 protons, but remember it's osmium protons plus neutrons. And this 190.23 is in the periodic table. You don't want to use that. You want to use a whole number. Okay, so another type of notation here is, and I like this as isotopic notation, where you don't have to use the periodic table. You have the atomic mass up here. All right. I don't see anybody raising their hands that I can see. Sorry about that. So atomic mass. Okay, so you put the mass right here, which is the protons plus the neutrons. Okay, we call it just the mass because the mass is different than the atomic mass that's in the periodic table. And then we put the element there, and then we put the protons down here. Protons here forgot an O. Protons here, protons plus neutrons up here, right? And then this is the atomic mass over the protons. And notice they're all sixes, so these aren't changing, but these are changing because of the neutral neutron. All right, so let's change here. I'm going to skip this video. So isotopic notation can, you do not need the periodic table. All right, so it's written like this as shorthand. So we have X, which means any element can go in there. You put the symbol there. All right, and then we have A and Z, if I'm not mistaken, A and Z. So A is the mass, and Z is the protons. Okay, and the mass, these are all in whole numbers. You don't put in part numbers, whole numbers. Okay, A is the mass, so that means the 12 goes there. That's the A, and the 6 number of protons goes in the Z. Let me double check to make sure I got this right. Let's take a look. All right, so lithium 7. Okay, one more time here. See if you get this right. How many neutrons? There's the proton count up there. And lithium 7 has how many neutrons in it? How many neutrons in it? Hey, can we, all right, I'm going to have to clear the talk in here a second. I'm going to just lock viewers because people are not doing what I asked them to. Please don't do it. Asked. Clear. Okay, so how do we do? Good. Only had one person put down 1. So 4 or 3. So 7 minus 3 is 4. You guys are doing great. Somebody must have just misclicked. All right. How many? Now this is different. How many protons here, ladies and gentlemen? How many protons? Be careful. It says protons, not neutrons. How many protons here? I kind of messed up myself. How many protons? 8 seconds. I'm leading. We got 5 seconds. There you go. I get that. 12 out of 12. How many people got this right? Sabrina did. Hayden did. All right, 22. Somebody thought this was the not a number of protons. Remember, 48, okay, is the number of protons, 22, plus the number of neutrons, and that's 26, gives me 48. 22 is the number of protons here. The mass is always both, and protons and neutrons have about the same mass. All right, next question. How many neutrons does this have? First it asked me how many protons, now it's asking me how many neutrons. 16 seconds. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's in the shared notes. I'm sorry, Adriana, it's in the shared notes. You look in the shared notes. How'd we do? How'd we do? Uh-oh. Okay. Neutrons only. Remember, neutrons only. says neutrons. So 22 minus 48 is 26. 4 people, 5 people. Gosh, this is takes a lot of practice, guys. It does, it does, it does. It's confusing. Okay, the photo shown above the isotopic notation, which is an isotope of carbon what? Carbon what? What we doing? 30 seconds. Carbon what? Mansmayo. 20 seconds. There we go. What we do? Good. Carbon 14, you recognize it. Somebody put carbon 12. I'm not sure why they did that, but it has a 14. Okay. A, I got these backwards. Did I get that right? Yeah, I did. Correctly written. What symbol does A represent? What does A represent? The atomic number, the mass number, the number of electrons, the number of neutrons. There we go. Did you get it right? It's kind of written down. Okay, it's the mass number. Atomic number is Z. That's the number of protons. Okay, a mass number is the number of protons plus the neutrons. Last question. What's the name of this pictured isotope? What's the name of this one? Copper 63, copper 34, copper 29, and then whopper, hopper, bop. I don't know. What we doing? 30 seconds. 2 more to go. All right. See how you guys did. Sabrina, Hayden, Natalia, Steven. Okay, yep, it's copper 63. Remember, it's copper with the atomic mass. Okay, so this is the AZ, mass over the protons. And then if we write it the other way that we did, then it tends to be, okay, so who won this baby? Got Sabrina and Hayden and Natalia. Okay, so sounds great. Okay, so here is what I want you guys to do. Everybody besides those 3 people I asked. I might ask other people to come in, but I'm going over some things with some people. So here is the new link that I want you to do. Where are you? Go back to the homes, my library. All right, and okay, 7 more here. All right, so periodic table. Okay, so I'm going to share this with you. Oh, I'm going to open it up, I should say. All right, I'm going to assign as independent practice, continue. Hey, Adriana. Oh, I'm done for. Well, don't worry. It's a lesson, okay? So it tells you about it, right? This is it's a pre-idea here. So this is periodic table. All right, so go ahead and get in. Oh, I put it on the wrong link here. Okay. Control V. So, oops, Control V. Here is the link to that. Okay, so I'm going to open up a breakout room. And I want to talk to Keela, Luna and Noah in the breakout room. Is Noah here for me? Elroy, how are you? Two wrong. Not bad, Elroy. Did you come in a little late today, huh? Okay. Let me double check to see if there's anybody else that I need to talk to. Okay. All right, Tehran, I need to talk to you. Can I get you to come over and talk to me? I'm opening a breakout room. Okay. Join us. Okay. Okay, so I'm opening a breakout room and I'm going to assign you to it. I got 4 people I'm looking for. All right, so everybody else should be doing that periodic table assignment. Let me go and open up a breakout room. We got about 10 minutes. And Nikila, where are you? All right. And, oh, okay. Now, where did Aquila go? Gonna... There we go. Okay. Great. Okay, I'm checking my messages here. Adriana, you had a question. Did you get the periodic table assignment done? All right. We had a group. We have a group from yesterday, you mean? Oh, yeah, I sent another um, periodic table assignment on the public chat. All right, guys, that's what I was doing. Let me unlock you guys. All right. Okay, let's talk about this tomorrow. So I'll see you guys later. Thanks for coming up. Oh, I won't see you tomorrow. Remember, it's asynchronous day tomorrow. Let me double check. Okay, asynchronous day, review videos, quizzes lesson, 10/9. A Monday is the 3-day weekend. We are done after the quizzes. I send you guys anything to work on. I did that quizzes. Yep, the lesson on the periodic table. Yep. Did everybody get that done? Right. I'll let you guys get to your other class. I got to get to my other class. I got to use the restroom. See you. Bye bye.